Okay, so we're going to try out that strategy of evaluating a trigonometric function given some point along the terminal line. The terminal side of theta in standard position contains the point -6, 4. Find the exact values of the 6 trigonometric functions of theta. So first we draw out our angle, so we send it out so it passes through -6, 4. Now we want to think about what right triangle we're kind of evaluating here. We are always using ones that have the x-axis as one of our sides, specifically as our adjacent side. So we are not, for example, we're not going to draw out this triangle here. We're not looking for the right triangle that would be like above the terminal line. We are looking for the one that would be below it, right? The one that would look like that. Okay, so we're going to use the value -6 because we're going in the negative x direction, and +4 because we're going in the positive y direction. That means that the length of our hypotenuse should be 4 squared plus -6 squared, and that will give us our hypotenuse squared. If we just want the hypotenuse, we'll do the square root of all that. So that will be square root of 16 and 36. So I believe that would be the square root of 52. Yes. 52 probably divides by something. 13. Okay, so we can do square root of 4 times square root of 13, and we can call that distance 2 root 13. That's the kind of final simplified version. Okay, so we should be able to go from there. So put that into our picture, 2 root 13. Just quickly write out what all of our different trig ratios are. So our sine of theta should be our opposite over hypotenuse. So our cosine should be adjacent over hypotenuse, ka, and our tangent should be opposite over adjacent. Let's see if I can remember these ones. So I believe sine goes with cosecant, and cosine goes with secant. These are ones that I think most of our intuition is going to pair these the opposite way, so that co goes with co, but that's not the right way. So cosecant would be the opposite, hypotenuse over opposite, and this one would be hypotenuse over adjacent, whereas cotangent is going to be adjacent over opposite. Okay, so in this case, our opposite side is 4. Our hypotenuse is 2 root 13, so that's going to simplify down to just root 13, or sorry, we're going to have 4 over 2 root 13. So that's going to simplify down to 2 over root 13. Our adjacent is -6. So that will simplify down to -3 over root 13. Opposite over adjacent would be 4 over -6. Or -4, 6, either way. Flipping these over, we are going to get root 13 over 2. Root 13 over -3. And 6 over -4. Ones that I would assume that they would kind of change around if you're doing this on the homework based off like things not being written in standard form. So this one, if we wanted to rationalize the denominator, it would become 2 root 13 over 13. All right, we would take the top and the bottom, we'd multiply both parts by root 13 in order to rationalize the denominator. Okay, and I think that's all that it would take to find all 6 of our trig ratios for this particular triangle based off of the coordinate they gave us on the terminal ray.